So the question was asked about how to number alkanes, alkenes and alkynes. And so let's look at a couple of examples here. Okay, the rules for numbering or naming alkenes and alkynes are the following. So let's say that I have this molecule. Okay, so rule number one would be find the longest continuous carbon chain in the molecule that contains the double bond. And that's the new part, is it has to contain the double bond. So I might go 1, 2, 3, 4, 5. Then I would go 6 and 7 here. So that this is a 7 carbon chain. So this is going to be a hept. And then we'll work on what it is after we name it. Okay. And also, I'm not going to name this with EZ or with cis-trans. We'll talk about those in class. Particularly, it's going to take us, after we get through the naming, we may talk about E or Z. Otherwise, we'll talk about that later in the semester. Okay, so I just found the longest chain in the molecule that contains the double bond. Now, that's rule number one. I should probably say double or triple bond. Then rule number two says, okay, now we've got to number this. And here's what gets priority. What gets priority is we're going to number from the end closest to the double or triple bond. So that takes precedence. Okay, not the substituent, but the closest end to the double or triple bond. So in this case, if I numbered from left to right, I would go 1, 2, 3, and my first carbon in the double bond would be 4, whereas if I come over here and go 1, 2, 3, I've now hit the double bond in 3 carbons. So I would number from right to left. I'm going to go ahead and put the rest of the numbers in. Okay, so then what happens about tiebreakers here? So let's just say, for the sake of argument, that we had a double bond that was equidistant from both ends. Well, it wouldn't matter if the molecule's symmetric, but let me go ahead and just put the methyl group here. So if I had this molecule, then numbering from the left, 1, 2 would put the double bond at carbon 2. Numbering from the right, 1, 2 would put the carbon double bond at 2. So what I can basically say is that they're tied, and so now I would number from the end closest to the first substituent, but only if this is tied. So then if tied, we then go to number from the end that's closest to the first substituent. And then if we have a tie there, then we use alphabetization. We use alphabetization to break the tie like we do in a normal alkane. So in this case, since this is tied, going 1, 2 to find a double bond, 1, 2 to find a double bond, the methyl group is closer, so we would number it from right to left. And that's basically how we number. The first find the longest chain that has a double or triple bond in it, and then number from the end closest to the double or triple bond. If you have a tie there, then you use the closest, the first substituent, or the end closest to the first substituent, or the alphabetization as a tiebreaker, but you have to go with rule number 2 first. So up here, we have a methyl group at 3 and a methyl group at 6. So the name of this molecule would be 3,6-dimethyl. And then for double and triple bonds, we put the number of the longest chain. So this would be a hept with a dash. We put the number where the double bond, where the double or triple bond starts. So that's the number where the double or triple bond starts, which in this case would be 3. And then if it's a double bond, we put an ENE. If it was a carbon-carbon double bond, that's the suffix. If it's a triple bond, we would have an "-ine". So the name of this molecule would be 3,6-dimethyl hept 3-ene. And so reading that back, I've got a 7-carbon chain with a double bond starting at carbon 3 and going to 4, and I've got 2 methyls at 3 and 6. Would be how I would interpret that name. Triple bond is going to be the same way. So if we have a triple bond, and then let's say over here we had like a bromo, let's say I had this molecule. Well, the longest continuous carbon chain, there is only one. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be an oct. It's going to be an oct-ine, since it has a triple bond in it. So now we need to number from the end closest to the triple bond. And so in this case, it would clearly be 1, 2, 3, and then 4, 5, 6, 7, and 8. If that substituent only counts if there's a tie and both ends are equally distant from the triple or double bond. In this case, the closest to the triple bond is clearly from the left. So that puts the triple bond at carbon 3. So this is going to be an oct 3-ine with a bromo at carbon 7. So this would be 7 bromo, oct 3-ine.